Hello, we are Team 3, who will present about Louvre Abu Dhabi this time. Today, we will talk about all the Louvre Abu Dhabi. Let's start. Abu Dhabi is the capital of the United Arab Emirates. Abu Dhabi worked in the culture and tourism industry for urban development and image linear of oil-producing countries. That is the Saadiyat Island Culture District. The first building in the Saadiyat Island Culture District is Louvre Abu Dhabi. The Louvre Abu Dhabi is the first overseas annex of the Louvre Museum in France. The construction discussion process was difficult because it was a museum. There was anxiety about the transformation of the National Museum into a global brand. Also, an international problem with the transfer of artworks abroad. After a long compromise, the construction of the museum began in the name of accepting difference between cultures and for globalization. It was architect Jean Nouvel who designed the Louvre Abu Dhabi. Jean Nouvel has painted Abu Dhabi's Middle East color on top of the brand image of the Louvre. Based on palm trees of the oasis, a dome-shaped roof was made. Underneath, buildings based on the traditional Arab village are built. Also, the building was surrounded by the sea, so the building was designed in the form of an island on the sea. After the design was completed, the construction of the building began in earnest. Louvre Abu Dhabi is located on Saadiyat Island. It was built on the sea to make buildings like islands floating on the sea. .3 meters of rock was placed to create a temporary constraint to prevent the inflow of seawater. The water in the closed area was filled with a filled material, and concrete piles using the MIP method were driven. The ground of Saadiyat Island was composite of sand and gravel layers, so the MIP method was stubborn. The hydraulic cutover was made with the piles by the MIP method to protect the structure from the sea. A total of 1,250 meter MIP bars and 170 meter circuit pipe bars was built. On the ground surrounded by the bars, a pump was used to drain water 7 meters below sea level. 50,300 cubic meters of sand were excavated while the water barrier was built and the ground was drained. The land was excavated differently at 7 meters and 3.5 meters depending on the location of the building. Concrete piles and steel piles were embedded above it. The 25-meter long foundation piles served as an anchor to hold the building to prevent it from the floating in the water. Steel piles may be added in length with additional pile joints until the approximate depth is reached. It is useful on Saadiyat Island, where the depth of the bedrock varies. After all the foundation piles were built on the excavated ground, concrete was placed to make the left slab. The left slab was first placed at a depth of 7 meters, and after all, a temporary steel tower was built. After that, waterproofing work was carried out to protect the concrete foundation. Waterproofing is essential because salty water, which causes corrosion in everything, is the enemy of museum and the precious objects they preserve. A water bar was placed on the concrete pile and waterproof concrete was poured into the upper part to form a waterproof membrane around the piles. The steel pile was coated with an anti-corrosion coating and the cathode system was wired for corrosion management. A two-layer waterproof membrane system was installed on the concrete foundation. For the lower geomembrane, 1.6mm thick TPO silica flame membrane was selected, and for upper geomembrane layer, another 2.5mm TPO silica flame geomembrane was selected. Each layer was subdivided into a hot seal compartment and checked for leakage through a vacuum test. All waterproof systems were monitored and controlled through a 3,450-meter cable and 3 advanced digital control panels. In this way, the foundation work to build Louvre Abu Dhabi is over. After the foundation, the dome was constructed.
The biggest attraction of the Louvre Abu Dhabi is its dome-shaped ceiling. The geometric design of the dome comes from arabesque, a traditional Arab pattern. 8 layers of this arabesque pattern layer consist of 4 outer layers clad in stainless steel and 4 inner layers clad in aluminum separated by a steel frame 5 meters high. The pattern is repeated at various sizes and angles in the 8 superimposed layers achieve gradual transformation. The concept of lighting studies for the density was provided by museum building with maximum amount of daylight on the glass roof while water and public plaza area should be in the shadow. Each star's elements of the dome fabricated by the aluminum extrusion of each unit with powder coating and final cutting and assembly. The assembled 7,850 pieces of the stars will be delivered to the site and prepared for the installation. As construction began in the center of the dome, the components of the dome were installed using crane with a capacity of more than 1,600 tons. A total of 85 mega elements were all fixed in place, and 120 temporary towers supported the structure to create a steel forest. For the dome construction using temporary tower support and provide crane, they had to overcome a few issues. The weight of the steel frame was similar to the crane's maximum lifting capacity. Therefore, there was the risk that the crane would fall forward due to vibration while carrying the super large steel frame. There was also a possibility that the temporary support base would collapse under the weight of the crane if it was moved close to place where it was transported. To solve this problem, the safety of the crane was continuously monitored by a satellite connected to the German manufacturer, and super large elements could be placed in the desired location. At the top of the temporary tower, a huge segment of the dome was temporarily supported on the metal ball and socket probes. After creating the first dome segment, another dome support tower is created to withstand the load of next segment. Then, build a temporary steel tower between the 2 dome segments, as the current support structure alone cannot withstand them. After all the dome structures were connected, The dome was lifted 38 cm using 32 hydraulic jacks with a lifting capacity of 310 tons. After the dome structure was raised, temporary joints were removed and 4 6-ton bearings were installed to serve as permanent supports. The bearings include isolator and spiral sliding bearing. Isolator allow the structure to move under the dome when the earth shakes. Sliding bearings can withstand temperature change during the day and night under the hot sun. After the bearings were settled, the structure slowly built on the permanent support tower. Once the top part is finished, the zero-level draft slab is added. Then the temporary steel tower is removed to secure the workspace under the dome. The shape of the dome is created as it is today. Under the dome, there are individual 55 buildings including museums. Before the ground floor museum is constructed, the basement tunnel work had been carried out. The passageway for carrying the artwork was crucial. They dig up 200,000 cubic meters of rock and sand and use 11,000 tons of steel and 70,000 cubic meters of concrete to build this tunnel, 12 meters wide, 6 meters deep, and 1.2 kilometers long. Regarding the water, we dug a well at regular intervals along both walls of the trench and did the dewatering. In addition, the structure was prevented from floating by groundwater, and about 600 concrete and steel poles were drilling into the bedrock to hold the entire structure in place. The ground floor consists of museum area, main plaza, other facilities. All the facade of the buildings are made up of 3,900 panels of ultra-high performance fiber reinforced concrete, which can be resistant to strong heat and seawater. The outer walls of the museum can bend inside and out to prevent the rising and falling of the sea. Also, for the wave protection, the inside of the panel of the wall was reinforced with stainless steel. As the permanent and temporary museums are the key buildings on the site, the main on-foot entrance is provided to access the museum. When you go through security check and reception, you can enjoy the work in 23 permanent galleries. If you get out of the permanent museum, now you are in the middle of the plaza, the center of the wool building. Here you can continue to go to temporary exhibitions, children's museum, collecting treatment, restaurant and cafeteria, and auditorium. After both the dome and the building are built, water finally enters. The first step is to deactivate 15 of the 18 pumps. It allows the water level to rise slowly at a controlled rate of 15 cm per day around the basement of the museum located below the seabed area. As water flowed back in, upward pressure was generated in the structure. At this time, the 25-meter foundation pile acts as an anchor. The second step is continuous monitoring of no evidence of water ingress in underground structure. The final step is to raise the sea level by pulling the more seawater inside the temporary wall and around the Louvre Abu Dhabi. Then they remove the hydro barrier and allow Louvre Abu Dhabi to be on the sea. Finally, the Louvre Abu Dhabi designed by Jean Nouvel was born.